Good morning. I welcome you all to the lecture series in control systems. Today's topic of discussion is stability analysis in time domain. In that, we are going to talk about Routh-Hurwitz criterion for system stability analysis. So, Routh-Hurwitz is based upon the ordering of the coefficients of the characteristic equation into a schedule called Routh array. So, we need to construct the Routh array given the coefficients of a characteristic equations. So, based on the analysis of the Routh array, we are going to come to a conclusion that whether the system is stable or not. For that, we need to analyze the first column of the Routh array. If the coefficients in the first column of the Routh array is positive, then we can find that the roots remain in the left half of the S-plane. If the coefficients in the first column of Routh array is negative, then we can say that the roots of the given characteristic equation or at least one root of the given characteristic equation lies in the right hand side of the S-plane. Or else if the coefficients are 0, then that indicates the roots of the given system may be complex conjugate roots which lie on the j omega axis, or there may be one or more roots on the right hand side. So based on this coefficient analysis, we can conclude the system stability like this. If all the coefficients are positive, then we can say that the system is stable. If any of the coefficient is 0 or negative, then the system is unstable. So with this introduction of Routh array, we will now see how to construct the Routh array. So given a characteristic equation of a system, if it is defined in general as a0 into s power n plus a1 into s power n minus n etc. up to an into s power 0, and that is equated to 0. Now the Routh array is constructed by first constructing the highest coefficient of the given characteristic equation s power n is written on the first row, and it is constructed with all even coefficients like a0, a2, a power 4, a4, a6 etc. And the second row of Routh array is constructed by taking the odd coefficients a1, a3, a5, a7 etc. So the coefficients may go up to the given power of your equation. So the first two rows of the Routh array are constructed with the given characteristic equation. Then we need to construct the third row by using this formula. The first coefficient of third row is written as b1, where b1 is equal to a1 into a2 minus a0 into a3 divided by a1. So it is just a determinant multiplication or finding the determinants taking the columns of the Routh array. So take this first determinant, find the value, that is a1 into a2 minus a0 into a3 divided by a1. That is b1. Similarly, b2 is found as a1, a4, right? Take this way, a1, a4, then a0, a5 divided by a1. So a1, a4 minus a0, a5 divided by a1 will give you b2. If you want to find b3, then you take a1 into a6 minus a0 into a7 divided by a1, then form b3. Likewise, you can go on finding b4, b5 etc. depending upon the coefficients available in the previous two rows. Then coming to the next less power of s, it is s power n minus 3 row. Then the coefficient is written as c1. So how to form c1? Again c1, c2, c3 etc. are framed by using the previous two rows, by using these two rows. So now we can find c1 again by finding the determinant. Now you take these two determinants like b1, a3 minus a1, b2 divided by b1. Then c2 is found as b1, a5 minus a1, b3 divided by b1 will give you c2. Similarly, we can form the coefficients keeping the first column as constant and adding the remaining columns to the determinant. It is a 2 cross 2 determinant. You can find the remaining rows likewise, and till the constant row s power 0 is found. This is how we have to construct the Routh array. Then after the construction of Routh array, analyze the first column of the Routh array. So this is the first column of the Routh array. By analyzing this first column, we can check for the coefficients sign. If all the coefficients are positive as we have told earlier, then it gives the roots will lie on the left hand side of the S-plane, so the system will be stable. If any of the coefficient is found to be negative, then it indicates that might be some of the roots in right hand side of the S-plane. So based on that, we can analyze the system stability. Now we will move on to an example of how to find the system stability. So we will take up a problem here. Check the stability of the system with the characteristic equation given s power 4, 8s cube plus 18s square plus 16s plus 5 is equal to 0. So now we will construct the Routh array. So the Routh array is constructed first by taking the highest power of s as the first row. We have the highest power of s as s4. So s4, the first row is constructed by writing the even powers, right? So it is the first coefficient is a0, s power 4, the coefficient of s power 4 is 1. Then we have to take a2, the value of a2 here it is s square, its coefficient is 18, so write 18, and a0, a2 and a4 the coefficient value is 5. Then construct s3, that is Sn minus 1 here, Sn is 4, Sn minus 1 is 3. So it is constructed with taking the odd powers of s. So it is 8s cube, so it is 8, it is s cube, 8s cube plus 16s, so it is a1 and a3 is 16. Then after that we don't have any terms. If you don't have any term, you can fill up that with a 0. Then S2 is to be framed now. So that S2 is our B1 term. So as we have already discussed, B1 is framed by taking the determinant value. So 8 multiplied by 18 and 1 multiplied by 16 divided by 8. Here in this, if you have a possibility of reduction of this row by dividing by a common divisor, you can reduce that. So S cube we can reduce by dividing it by 8. So when you divide it by 8, you can have this as 1, 2, 0. Now we can find the value of s square as you multiply this one. 1 into 18, 1 into 2. That is, B1 is framed as 1 into 18 minus 1 into 2 divided by 1. So 18 minus 2 is 16. 16 by 1 is 16. So in the S square row, the first element is 16. The second element is formed by taking or by multiplying 1 with 5 and again 1 with 0 and divided by 1. That is, B2 is framed as B2 is 1 into 5 minus 1 into 0 divided by 1. So 1 into 0 is 0. So we have 1 into 5, 5 divided by 1 is 5. So we have formed the S square row. Then coming to the S1 row, S1 is again you have to use the previous two rows. So you have to use S square row and S cube row. S cube row you take 1 and 2. Now use 1, 16 and 2 and 5 as the elements and frame the S1 row. So S1 row is, you take it as the element C1. C1 is equal to, again you use this value, 16 into 2 minus 5. So it is 16 into 2 minus 1 into 5. So we will give divided by 16 minus 1 into 5 divided by 16. So 32 minus 5 is 27 divided by 16. So that value is equal to 1.7. So you can write here as 1.7. And this element is framed by taking 1 16 into 0 minus 1 into 0, both elements will be 0. So we will have a 0 here. Then we need to form the constant or s power 0 row. So s power 0 row is formed by considering these two rows. So we can write 1.7 into 5 minus 16 into 0 divided by 1.7. 16 into 0 is 0. 1.7 into 5 divided by 1.7 will give you an answer 5. So we have completed the Routh array. Now we need to analyze the first column of the Routh array. So this is the first column of the Routh array. Analyze this first column. Here we can see that all the coefficients are positive. All the coefficients in the first column of the Routh array are positive. Hence the roots lie on the left hand side of the S plane. Hence the system is stable. The system is stable. So this is a system is found to be stable as far as this case is concerned. We will take up another problem where you can check for the stability of the system given the characteristic equation as 3s power 4 plus 10s cube plus 5s square plus 5s plus 2 equal to 0. So once the characteristic equation is given, then we need to construct the Routh array first. So Routh array is constructed with the highest power of s of the given characteristic equation. The highest power of s in the given equation is s power 4. So take s power 4 here. Then we need to take the odd coefficients of the given characteristic equation. Let this coefficient be a0. This is a1, a2, a3 and a4. Then we have to take the odd coefficients of s. Then write down the odd coefficients of s. So it is a0, a2 and a4. So a0 is 3 and a2 is 5 and a4 is 2. And construct the second row of the Routh array. The second row of Routh array is constructed with odd powers of s. So it is a1 and a3. a1 is 10 and a3 is 5 and there is no term here. So fill this term with a 0. Then we need to proceed to find the remaining rows of the Routh array. So the remaining row, the first remaining row is s2. So it is constructed using the S4 row and S3 row. So find the determinant value of the first two columns. As I told you, you can reduce this value as 10 and 5 are divisible in 5. You reduce this value by dividing this row with 5. So S cube row you divide it by 5. So that you will get the value here as S cube row, you can rewrite this as 2 and 1 and here is 0. 2, 1, 0. Now proceed to find the S square row. So S square row is found by finding the determinant value of this row and this row. So multiply these two values. So it is, we'll have this element as B1. B1 is equal to 2 into 5 minus 3 into 1 divided by 2. So it is 10 minus 3 divided by 2. It is 7 by 2. 7 by 2 is 3.5 here. So write there as 3.5. And find the next element of S square row. So you use these two rows and this one. You have this element as B2. So B2 is equal to 2 into 2 minus 3 into 0 divided by 2. So this is equal to 2 here. So write here as 2. So that's all. We don't have no more elements in S power 4 and S3 row. So S square row is completed. Come to finding the next row. It is S power 1th row. S power 1th row is found by taking the two rows, that is S cube row and S square row. So we got S cube row and S square row. So we got the elements 2, 1, 0 here and 3.5, 2, and if you want you can make it as a 0 here. Now this is to be found. So consider these two elements. So you keep that element as C1. So C1 is equal to 3.5 minus 4 divided by 3.5. So we'll get the answer as minus 0.142 minus 0.142. 142 it is, and you have to frame the next element. So use these two elements. Since both are multiplied by 0, naturally we are going to get a 0 here. So complete the S1th row. So it is completed. Come to the last row. It is S power 0, or which is a constant. So it is found by multiplying these two elements. So you can have this row as again 3.5 into 0, there is no element here. So 2 into minus 1.42 divided by minus 1.42 will give you 2. Now analyze the first column of the Routh array. So this is the first column of the Routh array. Analyze the first column. So from the first column, we can say that the coefficients are all coefficients are not positive. There are two sign changes. Here is one. Positive to negative is one sign change, and negative to positive another sign change. There are two sign changes, which indicates there must be two roots on the right hand side of S plane. Hence, the system is unstable. System is unstable. So, this equation which belongs to the system is unstable. This is the conclusion. As far as for the given system is concerned, the system is said to be unstable.